Hello all, welcome to my channel. I'm back with another video in which we are discussing alternatives to certain well-established tools which have become a pain to operate at a large scale. We discussed Kafka, we have discussed Spark. Now we will be discussing another tool which is synonymous when it comes to logs, which is OpenSearch. So in this blog, we will see what are the alternatives that we can use to work around with the limitations of OpenSearch. So let's get started. So when it comes to building log search or log analytics, the default answer that used to come for a long time was Elk Stack, which is Elastic Log Stacks and Kibana. So Elastic is the company which as of now supports Elasticsearch. Logstacks is for log collection, and Kibana was used for creating visualizations on top of it. And also it provides a unified search engine that we can use to query or to interact with the logs that which are there. And it used to work very well. It has been the go-to tool for log analytics in on-prem systems. Uh, but overall, over the time, it started to show its downsides. The reason for that is because it was not built for a cloud native architecture. It was built mainly thinking when it was built with a mindset that okay, things will be uh, in an on-prem system, and the scale might not have been that much. So that's where it starts to give up its benefits. For example, it had a very high cost of ownership because it follows the distributed nature, it follows replication. So each index or each segment has to be replicated across systems. Like say, for example, if we choose application factor of 3, then it has to be replicated in 3 different AGs, so 3 copies of the same data. With increase in volume, the amount of time it takes to index a document was also increasing day by day. It was difficult to scale after a certain size because each of the node can only handle certain amount of data, and with larger and larger scale, it started to be give the symptoms that it won't be able to process huge amount of data. It works well with a few hundreds of GBs of data, but when it goes to terabytes or even further, it's becomes very difficult to maintain. So there were other approaches as well. First, Humio came. It tried to overcome the challenge of Elasticsearch by following its unique index-free architecture, where there was no indexing involved. They had a different approach to get the searches work well. Then few others also tried to achieve cost efficiency by using object storage. Uh, and then few added indexing on top of the analytic warehouses itself, like ClickHouse, StarRocks, Doris. So when they started to support log searching, things become more easier for people to try out a few things. So what is that Elasticsearch was a great tool for full text search, and ClickHouse is a great for analytics, and that's where they thought, okay, why not combine both of these and make a unified log analytics solutions on top of it. And that's where the company called SigNoz came into picture. So SigNoz is an open source tool which provides a whole observability platform, but log management is one of their features. And how they do it is they leverage ClickHouse, which is a columnar OLAP database store, which what they do is they ingest the you have different apps. So they work on hotel or open telemetry collectors. So using that, they get the logs, they write those logs into ClickHouse, and then you directly query those ClickHouse logs. And for long-term duration or long-term analytics, you can offload that data to S3, and then you can have both the scale as well as the speed of analytic database engine. So this approach is what is one alternative, which is a, a ClickHouse based solution where ClickHouse engine is used for the querying and log parsing, and the storage is used as for the real time or hot data, it uses the disks which is attached to the ClickHouse system itself. And for older data, once the data is not that much of use, I mean, per se, like that is not needed for a real time basis, that gets offloaded to S3. And it has few other components like front end is written in React, which is and the query service and alert managers, those are written in Go. So that's the total design. And it because it uses S3, it reduces the cost of owning this log solution. Its dashboards, it supports dashboard creation, but it is not as powerful as Kibana or open source dashboards. So that is one downside. But again, this can be connected to other systems. For example, we can connect ClickHouse with uh, superset, and then we can work around the things that are not there in terms of the capability of dashboarding. So that is one thing to note. uh, how they work is they have so they will have Kafka clusters which do a log ingestion. Like it can be a Kafka cluster, it can be direct like this one as well, like the OTL collectors, or we can use decoupled system where we the applications write it to Kafka cluster, the logs, and then there is a log ingester which what it does it will do a batch kind of mode where it will ingest the logs from Kafka and put it into the loghouse ClickHouse cluster. And once the data is available in the ClickHouse cluster, the log admin tool we can use to create the indexes. We can use the lifecycle management of the logs to be offloaded to object storage. And then we have UI and APIs to query the data or logs stored in the ClickHouse cluster. So this is one good, nice alternative to Elasticsearch. Uh, the next tool that we have, which is which can work as an alternative to OpenSearch, is Quickwit. So Quickwit is a cloud native solution. So it follows the decoupled compute and storage. So it has stateless indexers and searchers. So this is the architecture of a Quickwit installation. So we will have object storage, which stores the indexes. Indexes are nothing but a searchable doc, which is split. And that gets stored on the object storage, and they have separate indexer service which creates index on top of the data which is present in the S3 location or the logs that we have. And then there is a searcher service which we can run queries to search the logs. And there is a janitor, which is the maintenance service, which does the regular compaction or any maintenance activity that happens on the platform is done by janitor. The indexers talk to Metastore as well as the searcher talks to the Metastores as well. A Metastore in this case is nothing but an Postgres DB where we store the information like which index split is mapped to which particular document set and stuff like that. The reason, the best part of this is that these components like indexer, janitor, and searcher can be scaled irrespective of the data that is present on the storage system. So there is no direct coupling between the processing capacity and the storage capability. Both two are independent, and hence it is easier to scale them. So if we need, let's say we are seeing a slowness in the jobs or the query, then we can add more indexers to do the indexing. And let's say if multiple people are querying concurrently, we can add multiple searcher itself, multiple instances of searcher. So that makes it easily scalable solution. It has capabilities like full text search is there. The API is compatible with Elasticsearch. So if we have already applications which are running an OpenSearch or OpenSearch Elasticsearch client, we can just switch it out. It has support for OpenSearch dashboard. So the once we have built this solution, we can use OpenSearch dashboard connected with Quickwit to just see the dashboards or create the visualizations. It does a sub-second search on cloud storage because it uses the indexer and searcher algorithm. So there are other things like schema-less or schema indexing is supported. Supports for Grafana is also there as a visualization tool or as a data source plugin. And also Kubernetes. This system can be deployed completely on Kubernetes because this is cloud native and it has been made. There is a help chart which is available that we can use to deploy it on our system. Just for an update, so it is written in Rust. It uses the tentative log search library, which is used for the search engine. In this case here, the searcher uses the tentative, and it is very tentative is very common and very growing library for log searches. So this is one thing to note. It has chit chat cluster membership protocol and I'm recording wall, which language is a fast language detection tool. So there are some details are there, which makes it uh, more suitable for enterprise grade log analytics solution. It was later on acquired by Datadog, so I'm not sure it is available as a free tool now, but it is part of Datadog now. And this is in production at Binance, it is at Menjumo, Formal, Radiant Security, Matter Labs, and Fly.io. So this solution is already in production at multiple places. SigNoz is also in production at multiple places, so that is also something we should note that the tools that I am mentioning are already production tested. Let's move on to the third tool, which is Parseable. This is again an open source cloud native database for logs. It supports ingesting data on object storage as a Parquet format, and then on top of it, we can run queries that we want to uh, do the querying or analytics. And basically, what it does, it uses data fusion engine so the logs are written into object storage using Parquet, and they have an index on-demand indexing and query node. So query engine that it uses is data fusion, which is another open source project which is written in Rust and is an competitor to Apache Spark. So it brings those capabilities of a single node large scale system that can process, and it also has intelligent tiering. Like it's not always that it will go and fetch data from S3. It will fetch and do store in the SSD cache for future further queries that happens on the same data set. So that caching is something which powers the faster response times, and we can create indexes on demand. So this is something which is a new, not that battle tested, in a sense it is not that much in production, but yes, it is something which can be looked at if you are a small to medium enterprise company that you are looking for a log solution. This can be uh, a viable solution because it is quick to start and it has all the plugins, like all the tools that is needed to make a system uh, be able to be called observed. And it integrates with Apache Kafka for ingestion. It follows Fluent Bit. It has Hotel connector as well. It also can use a eBPF, which is again optimized format of data transfer. So yeah, this Parsable is a good tool that can be used, and it has support for Grafana dashboards, and we can use this in our as a replacement to OpenSearch. Then the other common solution is Loki, which is Grafana Labs' log solution, which is again Grafana Loki is an open source, originally scalable, cloud native, multi-tenant log aggregation system developed by Grafana Labs. It is lightweight and it scales out very well, uh, but it doesn't have, I will say, that many. So it has some complexity involved. Like if you are on Grafana uh, license itself, let's say if you are using Grafana for other purposes as well, then this solution becomes very what do you call attractive, because this is completely managed and Grafana Labs will do take care of setting up and scaling down, scaling up for you. So if you are into Grafana ecosystem, then yes, this project Grafana plus Loki is the right solution, and it what it does, it has a distributor and an ingester. So the right path. So first the data goes to distributor, then the ingester will ingest it into the chunks on an object storage, and then we have querier which receives request from query front end and responds back with a result. So this Loki is a very scalable solution. It has an enterprise backing. It has a full support as well. And if we want to use Docker, we will have to use Docker with Pomtail, which is Pomtail is a query or collection framework which Grafana supports. So that Promtail Kafka consumer can ingest messages out of Kafka and into Loki for storing, querying, and visualization. So if we have decoupled system, we can use Promtail Kafka consumer. So yeah, this is one good solution if we want to have as an enterprise grade solution as an alternative to OpenSearch as a log querying solution. So Loki is there, a large interval data, particular event So these are some challenges, like it is not designed for querying high cardinality data. It is only for small things. And alerts on Logi is very hard. The idea is that doing alerts from logs is already against best practices. So we should not be creating alerts on logs. We should be creating alerts on metrics. So first thing is to create metrics out of the logs and then create alert out on top of it. So that is something which is a missing thing in this as of now. We can't create directly on alerts on the logs. Then we have querying the large interval of data. If we, let's say, last 90 days will time out, and dependency on Promtail, which is uh, the ingestion framework which Grafana supports. Possible to use fluently in log stacks, but I have not tested it out. With Promtail, it works very well. So yeah, this can be another solution as an alternative to uh, OpenSearch. Then there's a tool called Uptrace. Uptrace, again, it's an open source tool. It ingests logs using vectors, FluentBit, and CloudWatch, and it supports alerting for logs. So based on log severity, labels, or error or fatal, we can create alerts. It supports the dashboards using Prometheus like query language. It has support for Grafana UI because we can create a data source plugin from Uptrace to Grafana dashboard. Then searching logs with word, phrase, regex expression, and negative filters are supported. So this gives us kind of a full text search capabilities as well. And the structure, how it follows is it has hotel collectors, it has then time series database where it stores the matrix, traces, and some logs. And then we can do instrumentation, and third-party services can also be connected, and it can be launched on Kubernetes. So this is another tool which can be used as an alternative to logs, open source logs. Graylog, this is something which is not fully open source. So there are two versions of this. One is called Graylog Open, and then there is simply a Graylog. So the Graylog Open is a self-managed SSPL license centralized logging solution that we can use. It is an it it uses Elasticsearch itself to do the backend storing of the logs, but it is slightly more scalable because it stores data in it has it builds on top of what we call uh, Elastic, but it does a federation kind of thing. So that way it makes the uh, logging solution be scalable. So that this is something also we can use or look at. And then we have another alternative that is coming up and which is growing in what you call adoption wise in the open source community as well, or a data platform community majorly. The companies, what they are doing is they are simply swapping out Elasticsearch with Doris or Grafana. Doris plus Grafana or Superset. So this can not only limited to Doris, it can be ClickHouse as well, because both of those solutions are similar. So Doris and ClickHouse has both support open source analytics on log. So it has they follow the decoupled compute and storage, and it also supports querying data from S3. So what we can do is we can ingest the data, log data into Doris, create vectors out of it, or create log searching capabilities. We can use log searching capability directly if with variant data type. We can parse JSON and other things, and it has support for HTTP API as well, and it does support inverted index, Bloom filter index, BKD trees. So it has a lot of capability. It supports full text search as well, so we can leverage this along with Grafana or Superset to visualize the logs which are there. So for example, one company called NetEase, which is an media giant at in China, they have achieved a 70% reduction in storage cost and 11-fold increase in the query speed when they moved off their log solution from Elasticsearch to uh, Doris. Similarly, there is one another use case which is where the DB, which is an observability platform, they switched from Elasticsearch to Apache Doris for log analytics. Similarly, Tencent Music, they also have switched from Elastic to Doris, and they are saying storage cost reduction by 80% and write speed, the ingestion speed at a 4x faster compared to what Elasticsearch was giving. So this is an architecture from DB itself. So they have log collectors which send the logs to Kafka, and they have a Flink job which does a real-time ingestion of or what you call real-time query generation for Flink, sorry, for Kafka logs and put it into Doris. And there is a batch job which sends the data from, sorry, there is an ingestion framework which Doris supports, but directly can pull data from Kafka, and that also can be used in the batch mode. And then we have a search UI, Grafana dashboard, BI tools, or other MySQL API requests that we can make because Doris supports JDBC connection, so we can query the logs using all those tools. There are other tools as well. One is OpenObserve, then HyperDX, which is again ClickHouse plus OpenTelemetry, and then we have S3 plus KioSearch plus Kibana. That is another solution which is there. So explore these as well of your own. I will have a video on OpenObserve because I wrote a blog on this. So I will create a blog on a video on OpenObserve as well. But yes, in summary, we have Elasticsearch that we can use if we have the support, we have the engineering capability to maintain it. But if that is getting out of hand, then we have certain other options that we can choose: SigNoz, Quickwit, Parseable, Uptrace, Doris, Graylog, or Grafana Loki. These are the alternatives which are there that we can look to see if we can replace OpenSearch with something which is manageable and that is scalable. So we'll come back with another video on something else which can be replaced as an alternative for other tools. So keep tuned to this channel. If you like, do share it, spread the word, and help me and help us grow together in terms of choosing right tools for the data platform or for any platform for the matter. So yeah, thank you. Have a nice day.